Hey everyone, my name is Dr. Dan, and today we're going to be setting up a an augmented reality environment. And so let me switch to this cam. So I'll be using a Samsung Galaxy S4, and what we'll do is we'll set up a augmented reality environment so that we can place objects in the scene, see them with our camera, and then from the tablet move them around, scale them up and down, and rotate them with two fingers. And I think that the placing of the object will also add the ability to place different kinds of objects, and we'll pull some objects that are like worth interacting and placing. And I think that'll be a good setup for pretty much any augmented reality app you can dream up. So let's get started with that. I don't want to reinvent the wheel for augmented reality, so what I'm going to do is pull a library put out by Unity, AR Foundations from GitHub. So that is, I'm just going to grab their samples, which is in Unity Technologies AR Foundations on GitHub. If you have the GitHub desktop app, you can just open in desktop. Otherwise, you can grab that URL, download Git, open a bash script shell, and just git clone the URL like that. I've already got it. If you're curious, if everything I just said didn't make any sense to you, if you go to my YouTube channel, there are a whole bunch of videos. There are a whole bunch of videos I've put out for free for the public and the community to help developers just trying to make their dreams a reality. And you'll see that there's a virtual reality development environment set up. So the same thing we're doing here, but for virtual reality with the Oculus Rift there. If you want sophisticated AI, I have a few videos on making AI in Unity, especially using the Unity machine learning agents, which uses some Python in the back end. I've got a lot of web dev stuff, including making an AWS Linux server, making it HTTPS for free, and a lot of behavior trees, state machines, UI, networked virtual reality games. And these are all developed in conjunction with my, in conjunction meaning usually for students, but in conjunction with my program at Boise State University, where I'm a professor for the Games, Interactive Media, and Mobile Technology program, or GIM. So check us out. Please do enroll in Boise State University if you want to develop games and apps and make websites, especially with cutting-edge technology. Anyway, sorry about that plug. If you're wondering what I'm doing with Git, just pulling the code from the internet that Unity's put out, there are some tutorials about using Git version control in GitHub. These are about using Git for web dev stuff, but Git is just a great tool to have and to understand. So I just want to draw your attention to those resources, which are all available for you for free, the same place that this video is, on my YouTube site. Anyway, moving on. So let me fire up Unity Hub. Unity Hub, if you haven't started using it, do it. This allows you to install different versions of Unity like this, and then open projects with whatever version of Unity you want, with whatever target platform you want. So it's a great tool. I've had a lot of success working with it. The version of Unity I'm going to be using is 2019.2. Any version after that should be fine. So I have downloaded this code from the sample AR Foundation samples, and that they're just in my documents. So this is just the way that the folder looks right from Unity, and I'm just going to open it up right at that level. So it says it's created with a more recent Unity version. That's fine. So like I said, any version after 2019.2 should work fine. In fact, it should work better. Let me pause the video while this is downloading. Alright, so when we first open the project, we'll see that we have just a blank scene, but we have lots of stuff here. There are some animations to help us with moving objects around. There's some nice prefabs for things like a feathered plane, even a robot. That's kind of cool. So let's take a look at a sample scene and just make sure that we can build this to a Galaxy S4. So plane detection. Feathered planes sounds promising to me. The most important thing we'll need is to be able to detect planes in reality through the camera, and then we can instantiate things onto those planes. So got this scene open. Let's take a look. We have an AR session origin object, an AR camera. And that's it. Okay, that's fine. So let's just build this. I go to my build settings, and I'm actually going to select all of these. I don't want them all in the build. I just want this one. And you see I'm on PC, Mac, and Linux. I need to switch over to Android. So I'm going to select my Samsung device there that I'm building onto, and then switch platform. This will take just a second. I'll pause the video again. Alright, there we go. So we've switched over our build. We have that scene in the build. Now, I think I'm just going to move this around a little bit and turn off stats. I think it'll be helpful to see perhaps a cube. Let's just put it right in front of the camera and pull it forward a bit, like so. To see a cube in the scene, so we should see this just floating around in front of us when we build. So now I'm going to build and run, or Control B, and test environment, give it a name, and I will pause the video while this is happening. Okay, just about finishing here. Deploying, and I will switch over to webcam view. Sorry about the quality of this video. I'm actually using my laptop webcam instead of my camera. So as you can see, it's starting to build. That's great. So we should see, and we do, a cube right in the middle of the camera. And since it's adjusting with the camera, it just looks 2D. But this is in fact a 3D cube. One thing I'd like for you to be able to see is that in the background there's a texture. If I move close, you can just see those feathered plane textures. When those show up, we have tracked a plane that we can then place objects into the world onto in conjunction with that plane. So that's important that that's working. But good, so our test run, everything worked, and so now I'm going to build out a new scene. So let's go out of here and create. So I'm going to make a folder for myself here, which is going to be custom AR setup. And in that folder, I'm going to create another folder called scenes, and in scenes, I'm going to make a scene. So just to keep things kind of organized so I know what's mine and what's theirs. And let's call this AR testing setup, like so. Let's open it up. And let's see here. So first thing I want to do is in my main camera, let's make this a, let's rename it. This is going to be our AR camera. And we can call this solid color. And let's make it black. Then we'll want to, let's see, any other settings I have to change in camera. I think, for the clipping planes we can set it to like 0.1 and far to 20. And that's it for camera. Alright, so now I'm going to make two empty game objects, just like we saw in that sample scene. One called AR Session, and one called AR Session Origin. And make sure that they're both zeroed out. For transforms, I'm going to reset my camera's transform there. And I'm going to drag this camera into AR Session Origin, like so. On AR Session, we're going to add AR Session script. And we'll also add a AR Input Manager script. And then on Session Origin, we're going to add AR Session Origin script. And we'll pull the camera into there, like that. We'll need an AR Raycast Manager. We will need a AR Point Cloud, oops, not Point Cloud, but Point Cloud Manager. And I believe that's it. Oh, AR Plane Manager. AR Plane Manager. And we'll need a plane prefab for this. So in our prefabs here, we have a AR feathered plane and feathered plane fade. So for AR Session, I'm going to drag in that AR feathered plane right there. Alright. And you know, if you wanted to, you could just open up you know, this scene they provided, which is feathered plane, and just start from there, and you wouldn't have to set these up. So all I did was recreate these these settings here to some extent anyway. You see they have an AR camera manager there and an AR camera background and an AR camera manager. Focus mode auto disabled. Okay, so let's make sure we do that as well. So in our camera, let's add AR camera manager and AR camera background. Save that. Okay. We're going to need some buttons. So when we push a button, we are going to send things to the scene. You see, I've got this Text Mesh Pro. I don't really want that. I'm going to go to my package manager and just clean this up a little bit. So see here. Don't really want that. I'm going to remove it. Everything else looks okay. One thing I should draw your attention to is we're using version 3.0 of these, which is in preview. The actual package you can download from Unity is 2.0, so if you try and do this by downloading the packages instead of opening the GitHub repo, it's going to be a little different, and you may get some errors. Alright. Anyway, let's add some buttons. Build out our UI. So let's make one button, and can't see it, so that's not great. Let's make it bigger. Maybe like 250 by, actually, let's make it 300 by 150. Let's anchor it to the bottom left, and let's move it around a bit. Let's see where that is. Okay, so it's actually in view here. There we go. That was way out of scene. So I'm going to hit Control and have snapping on, and just lock it into that corner there. Good enough. Okay, so I know that looks super huge right now. In AR, it's going to be much, much smaller. We can actually just pull it down a little. Well, that's alright. Let's pull this up a bit. How about that? Alright, so let's call this place object1. Let's duplicate it, and this can be place object2, so we can demonstrate how to place at least two objects. And place object2, let's anchor to the bottom left, and let's drag it over to here. Okay. And actually, if we wanted, we could just add a let's see, horizontal layout group here, and get them nicely spaced. And then maybe like make them lower right. But I don't really want to mess with the padding, so I'm just going to Control Z, get rid of those. So the buttons aren't going to be exactly, perfect, but that looks good enough for me. One thing we can make sure is that the Y position is the same, so they are aligned like that. Good, okay. You see how this material too is kind of blocking our view? Let's make these kind of, let's grab them both. Let's make their alpha transparent, and that way we can still see what's going on behind them. And the other thing is their text. Let's select both of these. Let's make that like 20. Nope, not 30. Alright, and they can say place for now. Okay, so I have two buttons. We're going to need something like a UI manager. Let's call this button manager. And let's reset this transform. And this is just going to hold a script that changes things when we click these buttons. So let me open this up. Just to finish building out our UI here. Okay, so let's just have one method here. Well, let's have two public variables. So public bool button pressed, and public string pass the object name into the button so we know what object to instantiate, and then public void button press. Whoops. And actually we do want a string name parameter in there, and then what we'll do is we'll say button pressed equals true, so we know in other scripts that that button has been pressed, and we'll say our object name equals name. And why don't we debug .log button pressed with name, and let's pass the name into there just so we can make sure everything's hooked up in Unity. Alright, so over here in Unity we have this button manager, and in our canvas we have these two buttons. So I'm going to click on the first one, add to the onClick listener, drag the button manager in there, scroll down to that script, and button pressed is the method we wrote, and we're just going to pass the name of the object we want to instantiate. So let's say cube for now, and do the same thing here. Button manager, button pressed, and sphere. Alright, and while we're at it, we can quickly make two 3D objects, a cube and a sphere. Let's, in custom AI setup, create a folder called Prefabs and a folder called Materials. And in Materials, let's create a material called red and a material called blue. Let's set blue to blue and red to red. Okay, and then in Prefabs, we have a cube here. Let's reset the transform on both of these, so we don't get any weird transform errors. And let's give them colors. So let's make this blue and this red. You can see them. For scale, we can leave them at 1 for now, that's fine. And then let's drag these into prefabs. Like that. And then we can delete them from the scene. Okay. So we have some prefabs to throw into the scene. They're not very interesting at the moment, but we can change that later. Now we need to write a script that, let's put it right on AR Manager, that places an object into the scene. So let's create that and start editing. Alright, so the first thing we'll need is unityengine.xr.ar foundation, and using unityengine.xr.ar subsystems. And we're going to need a whole bunch of public variables here. So first we'll need two public game objects. So public game object, object1, public game object 2. These will be the sphere and the cube that we instantiate. In fact, just for readability, let's call it sphere, cube. Let's see. We want want a public, let's require, actually up here, an AR subsystems. So require components type of AR Raycast Manager. So we'll make sure we have that. The Raycast Manager for AR is what shoots like lasers kind of down into the scene, invisible lasers, but it shoots, you know, rays down into the scene, looking for planes on which we can place objects, right? So we need that, and we'll also need, while I'm thinking of that, a static list, which is going to be a list of our hits that we get with those lasers that shoot down into the ground looking for a plane. And we can call that AR hits. Equals new, and we'll make it static so we can access it throughout the class and in other classes. Raycast hit. Okay. Now, the other thing I want, well, I'm thinking of things that we can hit with raycasts. Let's have a public layer mask for testing, and we'll just call this ground layer. That'll be our test layer, so we can test AR things in the editor. And since I'm thinking about it, let's make that too. So over here in our scene, let's do a 3D object plane, and we can call this ground, and we need to tag this as a layer. So I'm going to add a layer, call this test ground. We'll also need a layer for objects later on, but for now, let's just tag this as test ground. Its transform is reset. Let's scale it to 5.15. And we can't see it yet in the scene, so I'm going to pull this whole camera up, and maybe like 3, maybe even 4, and then rotate it down 45 degrees. Maybe 40 degrees. I just want to be able to see the end of the plane there. Okay, so now we're looking down at that plane, and this is our test ground, not our ground. So we can test things out in the editor before we build to AR every time. All right, so let's get back into this place object script. One thing we can do actually is set this to test ground and pull the cube into cube and the sphere into sphere. Alright, now let's continue editing it. We'll need a few more things. Let's have just a standard game object go, so we don't have to keep making new ones all the time. And when we instantiate, and then let's have a public bool, let's see, public bool. So we may want to fire things slowly from our camera to the scene as if we're like shooting a projectile, or we may want to just suddenly place them in place. If we're firing them slowly, we'll need 2 variables, one that tells us we're firing and one that tells us to fire. So that's when we're shooting things like spheres and cubes or whatever, projectiles out of our camera into the scene. And we want to actually see that motion, right? Otherwise, we can just pop them into place on the plane that it finds, and either way of instantiating items in our scene, we'll want a public vector 3 last position to track our last position, a public float place speed for when we are firing, and should just be AR Manager. Oh, Button Manager. Excuse me. So a link to this script here, right? We'll want one of those. And then AR Raycast Manager, that's what I was thinking of. AR Raycast, coffee's done. AR Raycast Manager, let's just call it that lowercase. And that's it. In a start, we don't need, but let's make this awake. The first thing I want to do is get a link to the Raycast Manager. So get our component that we require called AR Raycast Manager. Okay. Now we're going to have to do something about when we develop this. The ground is going to be there right in our scene, and we don't actually want to see that when we're building to AR. So I'm going to deactivate that. You see that? But in our script here, let's see, a couple of things. So we need a link to this button manager. So I'm going to just drag that game object in and it'll find the script. I'm going to set my play speed to 2. And then I actually want one last thing here. I want one more public object, public game object, ground, and we'll say if we're in the editor. So how do we tell it? We ask application, are you in editor? And if we are, we'll set our ground set active to true. So that way we won't see the ground unless we're in the editor developing. Now we need to write our place object script. So void place object vector 3. It's going to take a vector 3 position. And what we're going to do is we're going to ask if oh, you know what? This script is called place object, so we need to call this something different. Let's ask if our button manager dot button pressed equals true. And let's handle the projectile case first. Well, no, let's just put objects in the scene. If it's true, then last position equals the position we're assigning, game object. So let's say go, our standard game object up there equals new game object, and say if our button manager name, if the name that we have a link to here from our button manager, the name that we're passing from our buttons, if that name is cube equals cube, then we'll instantiate the cube. And we'll say go equals instantiate cube at transform. If our button manager, on the other hand, has a name that is sphere, then we will instantiate sphere. Oh, yikes. Nope. That's transform. I forgot equals here. just spelled that wrong. Alright, so we've instantiated something at this point if our button gets pressed, but we need to set the transform parent to null, and then set the position to whatever position we feed in here. Okay? And at the very bottom, we need to reset our button manager button for rest to false again, so that we don't keep on instantiating things on a single button press. Alright, in update, let's make a vector3 here, position equals new vector3. Actually, we already, do we not have a, I think I have a position. No, I don't. Okay, that's good. So two cases, if we're in the editor, then we want to do something. Otherwise, we want to do something with AR. So let's handle the editor case first. So if we shoot a ray out from our camera, camera.main.screen, and we shoot it from our screen point to ray, and pass in a new vector3, which takes our camera main pixel width, takes half the pixel width, and then camera main dot pixel height, half the pixel height. I'm actually gonna make this 2 lines here, and then just 0, and let's put F in here, F. Like that. That should give us the right results for the ray. And then we want a Raycast hit, and we can ask our physics engine if our physics dot Raycast ray out hit 500F layer. Let's see, what do we have? Ground layer, we called it. Ground layer. So that's our layer mask. If we've hit the fake ground, right, then we will say our position is our hit dot point, and we will place our object. Nope. We will place at position. And that is the test case. Otherwise, we'll say we're in AR, right? So we need to use our AR Raycast Manager, and we'll send out a raycast from that. But again, we'll use our camera.main.viewpoint to ray, and open that up. We start a new line here. New vector3. And again, we're going to pass in half to get the right raycast results. And okay, and then AR hits, the static array of hits we have up there, and then we just need to specify that the trackable type is a plane in polygon, right? Because we're looking at a plane through the camera. Alright, so if all that happens, we've sent out an array and we've hit a trackable surface, then we need a hit pose object, and it's going to be our AR hits at 0 dot pose, and we can use that. Let's see, hit pose Position, we can use its position to then place an object at position. And that's all we need to do there. Okay. And that should be it. We can actually test this now. So let's just make sure we've got everything filled in. We're not going to use place speed. We're just going to snap these objects to their position. At the moment, we need a reference to the ground, and that's all we should really need there. Alright, so when we're testing, the ground should appear. It does. And if we place, we're firing, we've set up a new game object. Let's see where it is. It's there. But it's not actually the sphere. Alright, so let's see what's going on there. In our button manager, AR session, AR camera, in AR session, we have a link to our button manager. And our cube prefab is there, our sphere prefab is there. When we okay. Did we get a log here? Let's see, console, button press with name sphere. So sphere got sent to the script. So if we're in the editor, Raycast, camera domain, Raycast hit, if we've hit our ground layer, we're going to place at position. Place at position says, let's make a new game object, and let's instantiate. So we get to this point, and if the name is sphere, we should instantiate sphere, and set that to false. So look, the public string here is object name, and I was calling name, which was looking for this internal variable. Or actually, it's probably looking for the game object's name. So what we really want here is button manager object name. Button manager object name. Let's save that. This is the advantage to building a test environment, right? So we can debug these things right here in the editor. So there's our cube, there's our sphere. Very cool. Alright, so now I'm going to build and run, so Control B, and make sure that this works in with a device. I'll pause the video while that's building. Okay, we're copying the package here. Oh, we forgot to take that cube right in the middle out. No, we didn't. This isn't the right version. This is the old version. Alright, so I'm going to close this out and go to my Unity builds. Let's do this. This actually made it to the device. Okay. That's interesting. Did we remove the cube? Yeah, there's no cube in the camera. So we've never actually loaded. Alright, so I'm going to build this again. I'll pause the video while that's running. Alright, copying an APK. And there we go. It actually made it to my device this time. Okay. So, what is going on here? Is that cube still there? forgot to put this in the scene. Silly mistake. Alright. So, if we go to File, Build Settings, sorry about this, we want to actually remove this from the scene and add the open scene. Alright, let's build and run that. And just override that. Okay, last time. I will pause the video again while that's built. Okay, we're copying to the package. I see it loading. And let's get the main surface going here. So you can see I have these two translucent buttons at the bottom. Once we actually track a plane, which can take a little while sometimes. Actually seeing any planes tracking. Okay. So, let's take a look at why that's happening. So this is a problem with our session origin. We need a point cloud prefab is one thing. So let's go to our prefabs and AR point cloud. Go in there. And let's see, which one was that? Is that debug visualizer? Let's use the visualizer. Feathered plane is fine. Alright, let's take a look at our camera. One audio listener, that's good. Everything else seems fine. So let me just build that again. I forgot the prefab. Pause the video while that's building. Okay, we are deploying. Let's see if we actually get some. I'm not seeing a feathered plane show up. Interesting. Okay. Without that tracking, we won't be able to place objects. So let's figure out what's going on there. Okay. So let's go back to our AR session and just start from here. We have an input manager, that all looks fine. An AR session origin. We have AR session with a link to AR camera. We have AR Raycast Manager, Point Cloud Manager, Plane Manager with a feathered plane, detection mode, everything, AR Point Cloud Visualizer, testing ground. That all looks fine. Maybe it's a setting on.
Didn't catch that.
Maybe it's a setting on the camera itself. So my camera is solid color. That's fine. That's fine. Physical, nope. Near, far, 0, 0. Depth. Let's set our depth to 0 here. Not sure why it was at -1. Rendering path is fine. Occlusion calling, graphics settings, so on. AR camera manager is on focus mode. auto, AR background, camera. Okay. So I'm just gonna add a AR camera. We have that. Let's add a AR session origin here, and AR Raycast Manager here. And, oh, we don't need that yet. Yeah. Perhaps that will help. Let me save it. So I'm just thinking that maybe that those need to be placed on a different level. Let's see if that helps. Build this out.